Wait,
There we go.
there
It's
it
in my
is.
lazy.
What's
Okay.
lazy?
Oh no, the trailer.
Oh, oh my god! I've been waiting for so long.
uh, okay, the stream's up. Still gonna wait though. At least we know we're ready.
November.
Oh yeah. Good fall semester. Better take less classes.
God damn. God damn it. That's all they said. 2019, we're back. Back in 2019. God damn. God damn you.
His friend's not here either, so I can't invite him because he's not added on my account.
So I can't find the link to
It's
stream.
TBF V2 draft, a self improvement. Here, I can post it again, but that should
no,
have been.
I'm in V2 draft right now.
Wait, you can't see. That's the one, isn't it? That's the same one I posted, unless it's gone.
Oh, maybe I was still scrolling up. Maybe I just never got to it.
And the stuff.
Yeah, I see session 3.
Oh, there's a set. I posted it in DMs, but it should have said Sesh 4 May 19th.
Oh,
or May
yeah. I missed it. I just missed it.
I have a full, proper outline of the rest now, as you probably saw. Might as well
go in though.
Yeah, let's just so that's all there now. We're doing session 4 today. That's everything I want to do for session 4 if possible, but we're gonna cut it off strongly at an hour, so 10:30.
Okay.
So is there anything? I thought I heard something. Sorry. I explained the kind of game I was gonna make after the engine's done, if we do go that far, because I did say the cutoff was gonna be after an OO. I got some docs because we're gonna be needing to go over these, because there is some unportable code. I have some examples of loops we're gonna be going over. I guess the first thing we can do is I did organize our macros, so if you want that reorganization, I can copy paste this for you real quick. So get that here. So here's some commented organized macros. So I sectioned them off nicely. And yeah, we'll get started right here. So let me see that outline again. Is there anything before that? Oh, yeah, let's go over this. So I put some notes here on stuff you can do with the disassembler if you want to get familiar with it. We're going to be using it here too, but like one cool thing you can do is you can see the what the malloc is, how big it is, what the size of the assembly that's right here. You can also see the stack I think it's the stack getting allocated right at this line. So you see there's a countdown here on RCX that as you see it slowly go down, your memory stack items start getting formatted to CC. For whoever knows how many stack items you have. So once it finishes that, then you actually go into the code. So there's that. I found this thing called I haven't looked into it, but there's this feature called parallel stack, I think. Yeah, parallel stacks. Oh, I didn't. That's why. Okay. It's not really useful right now because we don't have we're not using procedural programming. But once we get into procedural programming, this thing gets pretty important. And the reason is it can tell you how many layers deep you are in code. So you see, like it tells me I went outside of main and now I'm in this thread of code. So we went to this address, so it considers that a level deep. And if we keep going to different calls, it'll keep going into deeper and deeper layers. So let's say you, since you know what procedural programming is, where you do function calls, it will basically let you keep track of how deep you are before coming back out. So it kind of gives you a point of reference, I guess you can say. And you can do it by tasks or by threads. So you have to load symbols for task apparently, which I might not have. But yeah, it gives you, I'm assuming this can get pretty nasty with something like C++. So it's got even a zoom out tool and a full screen option. I don't know if you can, doesn't seem like it has a full screen, but I don't see an option to pan. Maybe I can't because there's not enough information yet. But yeah, I just wanted to show you that. We're going to be using the memory mapper heavily. Not really the registers. The only thing I was going to emphasize, which we were going to go into more once we start messing with the addresses more, is you have to just to keep in mind that every time you're going to mess with something we have in the heap, you must put in the address, which that's more for Nick to know, since you already know this from computer system fundamentals. That's the only place you can do ALU operations from, is on the when something's on the register. So yeah, that's that. So now probably getting started with making the core engine loop, right? Yep. So let's see, we're 9:34. Just tell them last time. Okay, so we're still doing this imperative. So we're gonna be figuring out now how to make the engine loop, which the entire reason software engines are called software engines is because they implement an iterative cycle for all their code content past the starting area, I guess, for like initialization, and they have a closing after the engine's completion or exiting process. So again, that's why they call an engine an engine. As soon as you know what an engine is, it's just something that completely cycles constantly some sort of mechanical process. In this case, the mechanical process is hardware doing a logical execution loop. So we need an imperative code. The way you keep stuff, since you'll keep going down, the way you do it naturally is going to be using something called a jump. Now, if you do look at the disassembly, for example, for your source code, you may see a jump somewhere, or in a jump call from another function in here. You don't have direct well, I didn't see it there, but you'll see it in a moment, because what we're going to implement is going to give it. We don't have direct access to a jump call in C. Right here we have this instead, and the way this goes to statement works is basically the most raw way. Sorry, I keep hearing stuff out there. Hold on a second. Okay, sorry. So the rawest way to go from one line of code unconditionally to another line of code is using the goto statement. So C lets you put labels like that, so they can be some random ass label, will be white or some other color with a colon. And what that does essentially is if you put a goto statement to that label, no matter where you place this thing, you can place it up here, for example, it will go to it and it will ignore all the code within it can be in a completely different scope, it can be in a separate function even, and it will go to it. So you'll never see it used because people consider it unsafe and bad practice because there's something called procedural programming in C. But since we're not going into procedural programming until we get a certain amount of the engine done, we're going to be using this for all our procedural or routine-like code. So to make a engine, the simplest loop to do it is really an infinite loop. So we'll just make that first. So I'm going to call the first label a core engine loop just to designate it as the entry for that. So it's going to start there, and that's basically what I tend this label to do is that's going to be the entry point, the beginning of our loop. So when we do the goto statement like this, it'll just keep going back and forth, and you can see this run. Hold on a second, it doesn't like something. I'm trying to see what it is. It's possibly the way I set this up, it doesn't like it. 187. Yeah, so it's giving me an error because this is unreachable. The way you can tell it to shut up, since I wanted to just show you an infinite loop, is you go to here and disable warnings as error for now, and that should allow me to. So I'm pretty sure it doesn't care. So there we go. So now if you do the goto, it'll keep running infinitely for some reason. Let me put a single thing in here that's useless. So I'll put print message in here, just so we just do infinite hello worlds. So there you go. That's your simplest loop. In case Nick wants to review it, that's how it'll be done. But that's usually useless because now you have a dangerous program that will never end. Yeah. So you don't want that to happen. So what we need to do is we need to have an exit condition, or what they call a sentinel value officially. So the way we're going to do that is just a simple if statement. So the if statement lets you put inside this parameter scope here any degree set of conditions, and the restriction is that they must be if you can do it implicitly, but we're gonna just assume it's only explicit options. You have to have a bunch of comparisons between whatever data you're trying to compare with, and these are all your comparison options. So remember the bool I was making before? This is when I was gonna actually use it. So let's get started with making that Boolean type. So basically just make another address. We're going to restrict it to Boolean because that's the type we're going to be using. And we're going to call it exist. So all this is going to determine is whether or not the app should continue to exist and run, or leave and deallocate and exit. So to do that now, to populate it, we're just going to do the same thing we did with the character. We're going to call data so that we can dereference the get to the address's data point of the memory block, and then we're going to set it to true. I forgot a step, sorry. We need to give it the address. So to give it the address, it's the very first address of because of the way we have this organized. It's the character takes up the first byte after the bool, and the very first byte is the bool, so we can just make it equal to memory block. Like that. So don't have true defined. We need to make it then. So under your on C++ this is defined, but in C it's not. So in order to get the true type, for now we're just gonna use a macro, and we'll just call it true, and it's gonna be 1. And that's how they do it in stdbool.h too. So now we have true here. It's gonna like it, and we should test that. So if we run it, we didn't fill the if. I'll comment it out for now. Okay, so now we have our exist here. If we pass it, there it is. Notice that any value that's not 0 is going to be true. So if you could have this to 20 or 205 like it is here, and it's just going to output true. It can only be false if it's 0, which could be useful if you wanted to abuse that. Let's say you have a countdown.
What did you put in the if statement?
Oh, we haven't. I commented out for now because I was just gonna test this real quick so I could do it step by step for Nick if he's gonna review this instead of joining us. But yeah, like you can see that it said true properly. So now instead of saying true 205, it's showing just true because now it's just taking it as the value 1. So it takes it as its real value, I guess. And if you check the memory window, which I'm looking for mine, I don't know where it is, so I guess I have to bring it back. Oh, it's on this side. So if we check the memory window for exist, and let's go to it, you'll see it has the value of 0, 1. And you can see all the other hello world parts get populated afterwards up to the 21, and then it's send. So now we have our exist value, so now we can put it into a condition. So we're going to say if exist equals true, we're going to have our loop body in here. So now we have a subscope from function scope. So everything we do in here is not going to be known. Like if we do anything like instantiation, allocation, any addresses that we don't have outside of here will be forgotten afterwards. So you got to keep that in mind. So what I'm going to do now is, in order to make it so that it leaves the program after the core loop is done, is I'm going to have to go to inside scope. So then if this exists is false, it's just going to skip this scope and go straight to deallocate and leave. What I've just made is the very first type of primitive loop with a condition, which is called a while loop. The other one you probably heard of is the do while loop. The only difference between the while loop and the do while loop is instead of the loop body being in here, they put it in here. And then they just have this check happen at the end. And then it'll go up here and I'll do the loop body before it does the next check. So that's the only real difference between the do while and while loop. If you want a reference to it, I have it all in the Discord here. So if you just scroll up, you'll see all 3 forms. I also have a for loop, which we'll be using later, but don't need to right now. But I wanted to show you what it looks like because it's so popular. All you do is you have a data area that you initialize before you start your loop mechanism. Then you have your conditional, your body, and the go-to if it's not go to end of loop if it's not true, and then the stuff to do before it goes to the go-to to go back to start the cycle again. You're after, so like if you're incrementing an index, it would be there. That's basically what a for loop looks like in imperative code. So now that we have that, we have our core engine loop essentially. What I'm going to outline now is how the structure of this execution is going to be and what it's going to handle essentially. So the core engine loop is where basically after initialization. So if this is Unreal, for example, your game instance would happen before the loop. So it would be like a block up here, for example. And then once we hit into here, you get your UI update, your input update, physics update, render update. That all gets put into there because it has to happen constantly. And then what happens at the end is just deallocation of all dynamic memory, shutting down of systems that you don't need, extra processes that are running with the engine, stuff like that. So for the actual order of this thing, I have it in TA. Let me bring it out. I figured a good order for... You can put it in different orders, but this I feel is the best. So the first item we're going to be placing... or we're going to be doing the first item we're going to be doing too is going to be the input, because until we have a proper input system, we can't really interact with our engine properly for testing and stuff like that. We're stuck doing single test cases for the entire app instead of having some degree of freedom with how the app could change in its execution. So we're going to need the input for that first. That's why it's going to be the first thing you do. That's big. Next, I'm going to do updating UI, so I can update UI logic if it needs to before anything else. That's hardcore. That's why that way the UI is the most responsive out of all of them. Next, we're gonna, if it's multi-threaded, that is. Next, if it's single-threaded, everything's gonna just pop up and appear at once for the user. Next thing that's gonna happen is updating physics. So you should always have your input happen before your physics. Some engines don't do that. I don't know why, because it's kind of retarded. Because in order for you to know the proper next state of your physics should be in, it has to take into account what the player intended to do in the game. Because not everything, most things at least in most games are not procedurally generated physics events. They occur because of player action. So after that, we're going to update the state. So the state's going to be affected by the physics of the space. And that's where you put your main game logic in. And then after that, we're going to have the update render, which is going to be our text render. And that's when we update everything visually afterwards. So we want to make sure that if it's single threaded, everything that we wanted to have visually update, that we can visually show on the screen, happens after everything logically has been done. Otherwise, it wouldn't really make sense, and it'll cause some kind of dissonance if there's too much of a lag between updates, which there shouldn't be. The game should run at least on 30, but you can have hiccups, I guess, if it was a really bad performing game. So now that we have the loop oriented, there's one thing I didn't mention, and that's the timing system, which we're going to do right now, though. I looked into timing for C, and I had an idea. I was just double checking if they updated it or not, because I did this with George, and I already know that they don't have it, and that is a high performance timing system. If you go look at C reference and you look for timing support, which I have to look around, I don't remember exactly where it is. They essentially do have a C time is what it's called, and you can get time from that, but it's only accurate to like a 1.6 milliseconds or 1.4 milliseconds, which is good enough for a 60 FPS game if you wanted the accuracy of the game's physics and input to only be up to a frame. But for modern day gaming, where we have most of our screens at 144 Hertz, that's not good. So we need to go into Windows Platform API. So it's still not that bad though to do this. So don't be afraid of platform dependent code. So I already did the research. First thing as I did, I went to the C language reference to see if there was anything there, which I found is really great because it tells you specifically compared to the C language reference page here, which is like the standard. This tells you like the Microsoft specific version of it, what it has over that, because there is some features that you don't have in standard C that this has, and features that standard C has that this doesn't have. So you do want to keep that in mind. It also has clearer explanations than the other one does, much clearer. Like you read this thing and it's like a breath of fresh air compared to reference, the regular reference. So just wanted to show you that. After I looked around, I eventually found this page, This page is awesome. Basically tells you exactly what we need to do, which was high resolution timestamps.
Nice.
From the timestamps, we can do all the metrics we need for timing, which will affect everything we do. So that means our state logic and especially our physics logic. So let's say you have a variable frame rate and you need a variable delta to offset your physical changes to your movement. You need this because this is how you're going to produce your delta time. If you don't know what that is, I can provide a reference for Nick on physics engine basics, and because you do need to know, you don't need to know calc for this because we don't even do the integrals like calculus. It's more of like a multiple offset. So you just have to know how the timing works and how we get it, because it's a lot more practical and down to earth version, I guess, of an analysis or calculus. So yeah, there's that. You also have reference to all the time functions, which you can see the regular time functions that we could have used or the high performance ones. So the two ones we're going to be using are called query performance counter and query performance frequency. So I'll open those up. Let me see if I have any other links I wanted to show. So yeah, this is important. The query performance counter and frequency are accurate to the microsecond. Just to give you when they sample, that is. That doesn't mean our loop is going to be able to go that fast. Realistically speaking, our loop is going to be in the, I guess, not a millisecond, but like a 100 to 300 microsecond range is going to be our accuracy between loop updates with the way what we're about to be doing right now with no logic inside of it, just to keep in mind, and the way we're going to be doing it, because we're going to be using printf, which is expensive. So, and console updating that fast is expensive, so it's not going to be super low fast accurate like Unreal is. The counter basically just gets a raw snapshot. So that means you get a timestamp of exactly how much time has passed for that specific moment in tick counts. And then you get you would basically get the first capture and then the second capture. And then you would subtract them. And then when you want to find the amount of ticks elapsed in a second, you use the frequency to determine how fast on the system right now the frequency of tick is. And on my system, for example, the tick frequency is, I think, 1 million ticks per 100,000 or 1 million ticks per second, something like that. So yeah, that's what's going to be. We're going to implement that now. So in order to implement it, if you read the docs, it tells you that there's a minimum supported header, and that's windows.h. But I was looking at the Unreal code because they're a very good reference since we're doing an engine on, because I want to see if that's really the one we needed or if there's a better header file to reference from. So when I went to their documentation, let me see if I linked it. Oh, I only screenshot it. Well, it's here anyway. They included Windows platform time.h, and I looked into it. See if I can find it. And hold on, maybe I just have to do this.
Yep.
Oh man, I can't find my reference. Anyways, I think it's a more specific reference. If you try doing Win-based, you're fucked. It's not gonna give you shit. It's gonna ask you can't determine platform or something, so you would be forced to use windows.h, but I think this has too much stuff in it, so I decided to use Windows platform time. Oh no, sorry, let me see if that even works, to be honest. Hold on a second. I think that's something that Unreal did to include a specific header. Oh yeah, that's what it is. Sorry, never mind, just include windows.h. So that's gonna, sorry, I was looking into too many separate things. So, yeah, Windows H has it, which includes a bunch of other shit. But honestly speaking, you won't notice the difference because it's just going to compile it, and your memory increase is not going to be huge. It's still going to be so negligible, it doesn't matter. So, yeah, I mean, like these header files, there are a lot of information in them, but it only compiles what you use, I think. I'm pretty sure. Well, it depends on your compiler, to be honest. If you, it depends on what you pick. So, like, if you said, favor small code, then it would really be specific on how it does it. Since we did favor fast code, it'll be bigger. So now we have the reference we need to the two things, which is going to be Curie performance counter and Curie performance frequency. Now, notice, let's read this. So this is a function. We're going to look into this more with procedural programming, but it says it returns a bool Windows API, and it takes in a large integer address, and they call it the performance count address. So they don't use like a regular int64. They use this thing called large integer. You can search this up to see what the hell it is, and what you'll find out, this is why the Microsoft docs are awesome if they weren't being retarded. MSDN. Right there. So it tells you that it represents a native 64 sign integer. And you'll see this has this thing called long quad part. But if you decide you could, let's say you couldn't find these docs or you couldn't understand what these docs are, you could just put it in here to find out what it is. So let's just put one down right here. So I'm going to call this core loop prep area. And I'm going to put large integer. So now we get this little, notice the type because again, it's from windows.h, so we can find it. Now you can use a feature of Visual Studio called peak definition. And that will pop up this kind of like intersector window. They'll take you straight to the definition. And thankfully, this one wasn't hidden from us so we can see it. So we can tell that this is a structure. A structure is basically a combination of data types grouped together. I'll go more into that later when we get into ease of use functionality. But notice it has this thing, a quad part, a D word low part, and a long high part. What they're doing here is, remember, Windows is supposed to be a widespread compatibility operating system for old and new software. So what they're doing here is this large integer type supports both 64-bit integers and a 64-bit integer in a 32-bit system by splitting the bits up into two different types. So that's what this thing is. Unfortunately, we have to use it for this, so we'll be using it, but the final value that we get out of this entire thing, we can store into a regular data type after we extract it. But don't be too afraid of this thing. We handle it the same way as everything else. So again, we're going to need in order to do this timing system, we need two references to the snapshot. One at the beginning of the loop right here, and one at the very end before we do our goto. So let's make two addresses, and they're going to be large integer addresses. That's what they're going to point to. And we're going to call this one time snapshot initial. And then we're going to have another address, arch, try to use a IntelliSense here, there it is, time snapshot end. Now to store the frequency, if we look into it, it uses the same data type, a large integer. So we'll be making another address for storing the frequency to a large integer. And we're going to call that time frequency. Because that's not going to change. Once we get that, that's not going to be a snapshot. That's permanent. So now we have our three data types. And since we're doing all our allocation at once, we need to update this thing here. Now, to keep this clean, what we're gonna do for our allocation is we're gonna define a macro for all of our sizes that have like combo stuff. So our first one's gonna be defining the size of hello world. And that's going to be size of character times 13. And then we're going to do another definition for a macro. And that's going to be for our large integers. And since we have 3, we're going to do the size of, what did I call it? Time data? Size of time data. And then that's going to be the size of large integer times 3. And now what we're going to do is in here, we're just going to replace that with the size of hello world and the size of time data. So now to properly reference each new allocation, what we're going to do is get each address the same way we did the offsets here. We're going to give them offsets for the data here. So the way we're going to do it is we're going to say first time snapshot. Since time snapshot's initials the first one we care about, we're going to say it's going to be equal to, we need the address after message plus 12, which is the 13th character, and that's when the first of these start. So the simplest way to do that is to do message plus 13, and that will make sure to skip the 13th byte, but and go straight to giving this thing the right byte size. So now let me double check if this allows me to. I think it might throw me an error. Let me turn it to level 3 again, or level 4, sorry. Here you go. I mean treat warnings as errors, that's what I want. If I can find it. There it is. It shouldn't let me do this. Yeah, it's gonna give it a warning. What it's complaining about is it wants you to cast this thing before you do it. So casting is basically converting one data type to the other. Message 13, message is a character. So in order to get the proper type associated with this time snapshot for saying how you want to interpret this address, we need to convert it to saying that the address is supposed to be pointing to a large integer, and that way it confirms that our full intentions for what we wanted to interpret this address as was as a large integer to assign to this named address here. So now if we build, it should work, but I fucked up somewhere else. That's the condition. So this is an address. So you need to make sure to go from the address to the data, which I forgot to do, and that's why that screwed up. If I do this again, it's still another error. This is going to happen to you all the time because you'll constantly forget things. That's why your compiler is your best friend. It's saying that these two are unreferenced, so just comment them out because we just want to make sure that one works. So now it built for me, and we can see that if it was assigned the right address by doing what's called a format to the data there. So the way we're gonna do this is we're gonna just get the data to to that specific address, so time snapshot. And when you're doing this low level stuff, you definitely want to do this every once in a while. So you're gonna say data to time snapshot initial is gonna equal 0. And it's giving me an error, and that's because I forgot that this is a struct. So when you have a struct like this, if you could try to go straight to the data and equal it to 0, it won't work because it's got it right now. It doesn't know how to convert this thing to an integer directly. If you want, but if we look at the preview again, notice that quad part's a long, so we can assign that the 0. So the way to do that is simple. So we're gonna be when you have a struct, you can use what's called a dereference operator arrow, which basically says I want to select I want to get the data from this address for this specific part of the address, and we're going to be picking the quad part. And now that's going to equal to 0. Now it shouldn't complain, and notice we didn't have to get the data from it because it already did the dereference. If you didn't want to use that operator, you can just do, I believe, data and then dot or not. Never mind. I think you're forced to use it. I'll have to look into it later because I never, to be honest, I never bothered to do it.
You just melted my mind.
Oh, what's up? How long has it been?
I don't know.
Oh, okay. I need to catch you up, don't I? Or how long is?
No, I've been here for a while.
Oh, okay. All right. So, yeah. Again, don't worry about structs yet. At least you know they exist. When we finish, it was once we get the single input check done that I'm going to be setting up for you. The next session, I'll go over all the ease of use. And structures are an ease of use in my opinion. So I'll be going over them next session. But know that you can get to the different components of a structure by using this thing. Even if it wasn't an address where you were using something that was what's called stack allocated, you would use a dot instead. So if this wasn't an address, you would use a dot here. But since we're using an address, we have to use an arrow. So now let's test to see if this is allocated to the right address properly. And this time I'm going to show you it using the memory thing, so that way you can see it properly. So go to your memory block, like that. And I'm going to put this right here, because I want to focus on this and not the locals for this specific thing. So notice our memory block is CD for the entire way through. Which shouldn't be actually. Oh yeah, we were at the beginning. Yeah, never mind. So we're gonna be first setting data to exist, true. So we just assigned the true. So that means the first one should be formatted. The first one was formatted. Now we're assigning memory block. Memory block got assigned. Now we're gonna format the hello world. All those get formatted. Now we're gonna print the message, sorry. And now we're going to be doing time snapshot initial equals this. So now it shows you too right here which one that's getting assigned. So if we go next, you'll see that now it has the position AE. And now if you set that to 0, you'll see what part of the block it's in. Now this is actually perfectly fine because this is the bool. This is hello world, and this 00 is the null terminator. So we're perfectly aligned. What's called perfectly aligned. So we're right there because that's the start, and it's 1, 2, 3, 4, 5, 6, 7, 8 bytes long. So that's a 64-bit integer. So we're good to go there. So that's how you test them. And now we're going to do that for the next 2 addresses and then test those. When you're doing memory this way, where you use single allocation, that's what you do. And I'm going to explain soon what this is, because we are doing something manually that the compiler does for us. That's session 5, to be honest, actually, that I'll explain that. So we need to do time snapshot end. So since we already converted this, we can these are both the same size. We can just say that time snapshot end equals time snapshot initial plus 1.
Nice.
So we can say time snap initial plus 1, and we're good to go. So what I just did here is a compound. This is a way to compact your code if you're doing it this low level. So instead of saying equals this and then doing the plus 1 like I did here, you can just do the parentheses like we did here, and then just do it all at once before sending it over to snapshot end. Next thing we're going to be doing is setting time frequency. Again, same size, so we can just say time snapshot end plus 1 with the parentheses to mean that we're going to add it first before giving it the time frequency, because the parentheses give it precedence, because it's following again the order of operations. So now that we have that done, let's test them all out. So we're gonna say time snapshot and get the quad part of it because we're in a 64-bit computer. At least all of us should be. So we're gonna have that come out. We're not doing 32. If we did 32, this will give us an error, I'm pretty sure. And we're gonna do time frequency quad part equals 0. And now we can finally test all our memory. Remember to put your heap at the right place first so that we know what we're fucking with. Remember that this is the endpoint, so we should see after we get all formatted. Okay, so there's the 0. So now we're going to be assigning addresses. All right, so now we're going to be formatting. So this is the first one right here. So if you press F11, that's the first block. Let's try the next block. Perfect. Notice there's no CD between, so that means we did that. And now if we do the next one, boom. And that's our entire memory block, and we know we assigned each address correctly that way. Now, for what we're doing here, we don't need to initialize initial and end past the testing. So in order to be efficient, you can take those out since we don't need to format them. We only need and we don't have to do frequency as well. We only need to do something else afterwards, but we're not going to worry about that yet. So now what we're going to do is we're going to use the query time counter function. Performance frequency function. Counter function. Yeah, so the first one that needs to be done is the frequency, and that happens outside the loop, so that's the first one we're going to call. So that happens after we already sent addresses, so we're going to call query performance frequency, and we're going to give it the address to a large integer. Since time frequency is a address to an large integer, we can just pass it straight up. Like that. And that should handle it perfectly. So what this is going to do is it's going to grab that address, populate it with what we need, and then return a boolean. Since I'm pretty confident it's going to work, I'm not going to really check it. I'm not going to care about the boolean that it returns. Next thing we do is we need to do query performance counter. So we'll put that next. So we're going to take a first snapshot, which is going to be time snapshot initial. And there it is. And then at the very end of our loop, we're going to do query performance counter right here. So right there. And you just press enter. So now we have our two references. And let's see the engine properly format it and go through the loop. So I started the breakpoint too early. Let me just move it down here. Continue. Okay. Hold on a second. Did it just... Oh, hold on. There we go. Now it's starting in the right place. I'll go to the memory address, although it's not going to be as important since we can really use this now. So actually I'll hide it down here. So let's focus on here now. When we sign our addresses, all the addresses are signed. So let's see if query performance frequency gets its proper number. There it is. So this is how many, this is our frequency of ticks per second. So I don't know what that number is. It looks like 1 million. 1, 2, 3, 4, 5, 6, 10 million? I think it's 10 million. So there we go. You might have a different number. It depends on the CPU. Most 64-bit machines should be at that though. Next thing we're going to check is our query performance counter here. So we're going to press F11 on that. There's our first snapshot. Now we're going to check our end. There's our next snapshot, and you can see the visible difference in how much ticks have passed since before each snapshot. It is in real time. So now if we press the go to the core engine loop, it's going to go back outside of the loop of the if statement, check the if statement again to see if it exists as true, and then do another snapshot. And it'll keep doing this over and over again for ever until this becomes false, and then it leaves. So
When would it become false?
you would have to tell it that, or you can
Oh.
have a counter that goes down and affects it. So like, let's say you have an indexer that says it has to do 100 loops and then it leaves.
Right.
That's one way of doing it if you don't have user
You
input.
index with I and C.
You can do I, or you can name it index. It doesn't matter. It's what you want to call it. People like to use I because of calculus. If you ever did the summation sign, they traditionally make the index called I, and then they make it equal to K or something. That's where it comes from. But you can really just call it index. It's easier to find it that way, to be honest, and follow what's going on if you just call it a word. So that's what I want to emphasize design wise. Try to never call anything a single letter. That's something you have to unlearn from math. It's very bad practice to do that because you lose track of things too easily. Even for something dead as simple like an index, you should call it an index. Unless you have a better word for it. So let's say it's the counter for something, call it the counter for something instead of index. But if it's super generic, you can call it index then. But it's faster for your brain to figure out what the hell that variable is if it has a name than a letter. Because if it has a letter, then it has to go through the mental gymnastics to find out what that letter is. And for a math person, it's really fast to figure out with a formula. But when you're looking at hundreds of lines of code, hell no. So that's just something you have to keep in mind. But anyways, we got that down. So let's put some let's get some metrics.
Also, I have a shit ton of errors on my.
Oh, no problem. Let me go look at it. Let's see. Open. Okay. Go to output. That one has more. The problem with errors, it doesn't show me the order. Output does. So go to the output tab. It's in the bottom left. Because I want to see when it happened. 171.25. So go down to 171 and it said true undeclared identifier. Yes, but you missed that. So we made a new macro. So go up to your bool macro. There it is. So we're going to define something right afterwards. So it's called define true / and then we made that equal to 1. Now it should not give you trouble.
Just one like that?
Yeah, perfect. All it does is that's an enum essentially. We just enummed true to be 1.
Okay.
And now we have other errors. Good, we made progress. So go up. Don't ever worry about errors. They're usually easy to fix, and you expect half of your coding development to be errors, more than half of your time coding. 156. So it's saying illegal use of this type of expression. It should. Let's see what's wrong with it. Undeclared identifier. Did you ever define exist, by the way?
No.
Let's do that. Go up. Oh no, not there, not there. It's a variable we're using. So go down. It's right before, right after memory block. So after the allocate memory, there's gonna be a new line there.
Yeah.
Another one, and then we're gonna make an address to a boolean.
Oh yeah, he doesn't have exists.
Yeah, I don't know how to do an address to a boolean.
It's the same way you did the void one, but now you put something else inside of there. It's called a bool. But no, we made a new bool name, so we don't have to do the underscore. There you go. So now we're gonna call that exist. That's how you do a address declaration. So now after that, we're gonna assign exist an address. So say that exist right after, not there, after the existing, so we can keep everything together. Right, yeah, and then just put a new line and then put exist equals memory block. And the reason we're putting memory block is because it's the very first thing in our order of our block of where the bytes are ordered. The very first thing we said is we designated the first byte to be a boolean, and now we're finally assigning it. So that's what that was. And then of course message equals memory block plus 1 byte, and that's so it skips over the exist and has its proper alignment. So no, we already did that. If you scroll down, you'll see it. Message equals +1. Message +1. So that's where we did it. So now try building again. Let's see if we can get rid of some of those errors. We did. So now we only have one left. And that's the address to a large integer for message +13. Let me check mine. So let me go back down.
For size of time date.
Oh, that's times 3. You didn't we're doing 3 large integers. So you just say size of 3 large integers, which is size of large integer times 3. So just put a times 3 at the end. No. Outside of the size of. Size of gives you the number of bytes a large integer is, and then you're doing a multiple to multiply that value by 3 to get the number of different variables we're going to be having of data.
Oh, okay, makes sense.
So yeah, just space that out. Go back down now. If you check your address, when you do a cast, it needs to be inside of parentheses. So put a parentheses over the address. So one before address call and one after. And that tells it that expression's a cast of the message +1. No, before the message +1. So you put the parentheses right before. So you close it there. And it doesn't mean a multiply. It means a cast, because that's casting the type of message to that. It's kind of like, think of in functional programming, look at my screen, for example. In functional programming, or like, have you ever done logic programming yet?
No.
Okay, so there's this thing where you have a variable a. Okay, so pretend it exists, but the variable has no type, nothing about it. There's no attributes assigned to that type. In math, in order to give that type a attribute in logic, they'll say a is data like this. And that's kind of what you're doing here. So you're saying this message address, which used to be a character, we're overriding the type attribute of this data of address to be of a large integer address type instead.
Okay.
And if you don't get that, don't worry, it's gonna make more sense later.
No, that makes sense.
Okay, so perfect. So now try building that. You still got an error, 3 errors. Go to output. Core engine loop, unreferenced label. So you need to make a go-to statement. So C is very strict with your labels. Whenever you make a label, C forces you to have a go-to for it, because there's no reason that label should exist otherwise. Because the whole point of a label is to go to it. So your loop, the reason you had to go to, so that was a good thing, but you forgot to capitalize your L there, so it couldn't tell the difference. C is very sensitive to type casing. Now I could find it. Another problem that you have is, I don't know if you were here for it, but this if statement starts a new scope just for the if statement. And that scope starts from right here to right here. So everything that's inside of there needs to be encapsulated between those 2 braces, which define the condition scope. What that lets us do, and this is why our while loop works, is that everything, if exist is true, it goes inside the if scope. If it's not true, then it ignores everything inside the if scope and goes straight to deallocate, for example. From there, that's how your loop would end. Otherwise, notice at the end of the if statement, there's a go-to. That's what keeps it going on infinitely, so long as it exists as true.
Can I point to another loop? Like, I guess go to.
Yeah, you can point to whatever you want that you label. You just have to put a label somewhere and have it go to a go-to. It's how you basically do what's called jump calls or procedural routine routing in imperative programming, which is like you always go one line by a time. So if you wanted to change your routes, you can use a go-to to skip lines or to go to a previous set of lines.
And then the core engine loop, what is that? What would you call that? Just the name of the loop, or?
Yeah, I'm just giving the label a reference to what it's supposed to be doing, and it's a core engine loop. So this is our loop for the engine. So everything inside that loop is going to have everything we're going to be constantly updating for the engine. That's going to
So
be
that's a label
dynamic.
then.
Yes.
Okay.
And that's a jump label, essentially. It's a label to jump to. You can actually see it if we go to... You can see what assembly operation they use to make that work. So if you go to your disassembly, after you run your program, does it run, by the way?
Yes.
Okay, if you go to your disassembly and you go down to what's labeled the core loop, engine loop, notice that where the go to was supposed to be. So let's say you put a breakpoint to the go to and you go straight to it. There's a JMP and it leads to an address. So it says core engine loop label, which is this address. So what that jump's going to do is going to tell it to jump to that address location. And it's going to do all the lines up for that thing. So that's literally, go to is just another name for jump.
Okay. We're just talking about jump twos.
Yeah. So there you go. That's the... Now so you should be caught up now, right?
Yeah.
Got it. So now let's get some metrics started so we can have some valuable information from these performance counters. So the way that we were gonna do that is we're gonna make a new address, and this address is gonna be to a different value type though, which we have to define. So up under our data related, we're going to make a new type of data name, and it's going to be called int64. And that means it's an integer of 64 bits, which is 8 bytes. And the way to do a 64-bit integer, you do long, and it's signed. By default, all integers are signed. So it's going to be a long int. And that defines that. So now what we're going to say is we want to do an address for a long int. So let's put lint64 here instead for the shorthand. And what this is going to be called is loop time elapsed. So that's going to basically tell us how much text elapsed. How much time in seconds elapsed. We're going to be using these two tick snapshots to get that information. So this we're going to be printing out, so we want to initialize this one specifically. So what we're going to do is before our query for the frequency, we're going to say loop time elapsed equals 0. Make sure to do data so that you get the data of the address, because you don't want to be setting the address to null. And we also have to set the address to the data offset for our memory blocks. So that's going to be loop time elapsed equals, because now we want to actually set the address, not the data. Notice it's a 64-bit, but it's the one right after time frequency. So we're going to say time frequency plus 1, and we're going to convert it to our data type that we want, which is going to be a address to an int64. Okay, so once you've gotten that done, we can make sure that this new data type gets allocated. You'll notice that yeah, we didn't allocate it. We have to allocate it. So for size of time data, we have to add the size of this thing, or else if we try to do this address, it's gonna be fucked if we try doing the data. So it actually won't give you an error. Let me show you what it does, because this is an important error. It's gonna help you find your fuck ups with malloc, so you can actually see what that error pattern means to you. So if you breakpoint this right here, you run it. Let me ignore this assembly. I'm going to set the address. It's going to let me set the address. So you can see it's right there. And it's probably correct, to be honest. The address that is, where it's supposed to be pointing. So where is it? There it is. So if we go to it, it is the correct address. But now if we try doing the data setting, notice it didn't give us any errors. But watch this. So let's say I decided our program ended and I wanted to deallocate our memory block, right? This is why C is dangerous. The worst case scenario of why C is dangerous. So you messed with your data, your program ended, and you had no idea that you just messed with a part of memory that was never allocated to you, that you reserved. This error is going to pop up. It's going to tell you that your heap is corrupted. The reason why? Because you fucking decided to format a piece of data that you didn't reserve for your program. So that's its way of the debugger telling you you fucked up. So now if you looked over your program, you realize, oh, it doesn't allocate for that. So now you're just going to put plus size of our data type is an N64, and that will take care of things. So now if we try running it again, we will have that data allocated, so we can do data equals 0 and then deallocate, and everything deallocates perfectly. And if we go to the address of the memory block previously, you'll notice that everything has been cleared to DD. So that's how you know you're set. So that's something to look out for and be careful of when you don't have smart memory. We are going to have smart memory for the rest of the engine once we get past the point, because I'm going to make it with you. So you don't have to worry about this bullshit happening. So now that we have our loop time elapsed, we have to do the math to calculate the loop time elapsed. So the math is as follows. I followed documentation for this. You get the data of loop time elapsed, and we're going to be setting it to the time of snapshot initial end. The time of snapshot end first, and we're going to get the quad part of that again because that's what's storing our actual number for a 64-bit machine. And we're going to get the time snapshot end initial, get the quad part of that. This gives us what's called our tick delta. So this is the delta being basically the displacement of ticks between the first and second snapshot in a positive number, since we did the end first subtracting the initial, and this value is going to be an integer. From there, to make sure that we preserve, and since we're not using a float, we preserve the integer value, we do data loop time elapsed equals the data of loop time elapsed by the value of a tick, which is going to be 100. It's 1, 2, 3, 4, 5, 6 zeros. So to give this number context, let's make it a macro. Let me go find out what exactly this thing was called, because I already forgot it, for example. So let me get that real name out. It does tell you. Just need to find it. It's in here. Okay. So this is our 2 microseconds coefficient. So let's store the coefficient near it. So let's put it, I guess, here for now, until we have a nicer space for this kind of stuff. So we're gonna say time to microseconds offset, and I'm gonna give it the value of this. And that way we don't have to figure out what the hell that number is 3 months from now, or when you're explaining to your friends the engine you made like 5 years ago. There you go. everything's properly noted so you can actually explain it really fast and remember. So we have that offset done. So now we can do the division without having to worry about any loss of data. So we're going to say data loop time elapsed equals data loop time elapsed divided by our frequency. So that if you do time frequency, which gives you the the tick interval for the CPU, get the quad part again, and now if you do that division, we'll get the amount of ticks per loop, and let's test that out. So I'm gonna place my breakpoint right there. Build. Does anyone have any build errors?
Yeah, I got all the build there.
No problem.
I'm good. Oh shit! Your screen.
All right. You probably defined that. Yeah.
Time scene.
So let me give you that number. So that time to that time is this. I'm pretty sure. I can copy and paste it from here too, just to make sure it's the same size. And it looks like it is. Yes, it is. That's the one. So you have that. Why is it giving you an error? Because you... No, that's fine. Data... Oh, you did a minus sign. See your equal? Is that an equal? Or is that a minus? Oh, there's no semicolon. Notice your quad part? The end of that statement? There's no saying the execution statement's done. So there's that. And now loop time equals loop time elapsed times time microseconds offset. Try building that.
I had errors before we even.
Oh, no problem.
So I just
Output.
didn't want to stop you.
No problem. Scroll up. Let's go to 100.
It's return FN. Some bullshit.
No, something else is up. Go to your top macros. Something's wrong up here. So your long in. Is there a white space on the time 64 /?
Yeah.
No. Check. No. Afterwards. That's what I'm wondering about. Yes, there is. That's why. Can't be a white space there. It gives errors for that. Try building again. Okay, so now we have 170. At 170, we have an address to loop time elapsed equals time frequency plus 1. Well, you already defined loop time elapsed, so we don't have to put address there. So take out the address because we're just assigning the address. We're not define. We only use address there if you're trying to define a new address type. So we're saying time frequency plus 1. So we need to convert that.
Adding to the original address.
Yeah, so we need to encapsulate that in a parentheses just like the ones we were doing before.
Which one? Time.
Frequency plus 1. So just like that. Because we're saying we're going to give you what the address of this operation of adding to that original address value. And then we're going to cast it to an integer 64. So remember to do a cast, you have to put parentheses before these parentheses.
Okay. Parentheses before these parentheses?
Yeah, so right there. So opening and closing parentheses, and inside of them you're going to put int64 because that's the type of loop time elapsed. And that gives you, now that conversion should work, so press Control-Shift-B.
Wait, I did address to N64. Is it not that?
Where? Oh yes, you're right. You're right, Hazar. Put address to N64. I fucked up. I keep forgetting that. And then you have to put that in parentheses, by the way. Keep that in mind.
Yes. Exactly.
No. Before the after the N64, the parentheses closes. So you closed it the wrong area.
Oh, they're in the same.
Yeah. Well, no. There's an opening there, and then there's a closing after the N64, because address N64 close. So address of N64 type, close, cast time frequency +1.
Now I'm confused as fuck.
So look at time snapshot initial. Look at the format. It says parentheses, address of. Look at that. When you see that parentheses up there, that means address of a large integer, close parentheses, open parentheses. Here's what we're converting to a large integer address, message +13. And now there's another error. Output 120751.
What does the 51 after mean?
50 the column.
Oh.
It gives you both. If you had a column number, you could find that out, for example. So it's probably a spelling error. Yes, it is. Bingo. All right, so change your breakpoint to be the first query performance counter. Let me know when you're there.
Yep.
So we're going to do our first snapshot. There's our first snapshot. We're going to do our second snapshot. There it is. Now we're going to do the math. So first thing we do is we get the difference between the ticks. There it is, being stored in our loop time elapsed. We can see the exact number of ticks passed. We're now going to offset it to the number of microseconds that would be when we divide the frequency. So we give that multiple. So now when we divide the frequency by it, we'll get the exact number of ticks. The exact number of microseconds that had passed. And that's the amount of microseconds that passed.
Oh my
god. If your time frequency was different than the microseconds offset, then you would have gotten a different number. Since mine's exactly the same, this two different operations are effectively useless. But it does extra work. But just to be safe, like in case I ran this in a different Windows machine, you would want that to be there. So now if you keep looping that, you'll get the different amount of times. But this is annoying. And you want to see how fast your actual system runs at. So let's get a print in here. But here's the thing. So let's just try putting a print right here, okay, for example. So let's do print. And you're going to try putting the loop time elapsed, right? If you try doing this, it's going to give you an error. The reason is the print we've been using cannot handle numbers. So we need to convert that string to a number. Or we can use a more advanced print that I've been holding off on because it's more complicated. So you choose. Do you want to try to convert this thing into a number? Or do you want to use the more advanced print to do it for you?
No, when you say complicated.
It's more advanced, doesn't mean it's more complicated.
Oh, okay. I thought you used the word complicated.
No, I said more advanced. It actually would take less steps to do the printf, but might be harder to understand because we're not doing it step by step.
Do it step by step.
Step by step. Let's see how much let's see if we can find a function. If we can't, we're gonna have to convert a string to an int. An int to a string. Let's see. Cause he needs to know how to manipulate strings, but we're hitting time. So we might have to wait till session 5 for this. Hold on.
Yeah, sorry about the fucking wait, boys.
Oh, that's no problem. We started it. The review was only like 5-10 minutes, and you kind of catched up. So, I'm just trying to see, int 64 to string. They're gonna fucking use print, aren't they? Oh. Wait, no, that is it. Oh, that's C++. That's IBM. We're not using IBM. We want a pure C reference way of doing this. Does it exist?
How many LaCroix can one man drink?
Huh.
This and more tonight.
So C doesn't have a way of converting an integer to a string. From what I'm seeing here, at least an int64 to a string, which is what I wanted. Brr.
Just printf.
Let me just try int a string then. Let me see if I can fucking find that. Etoa. So let's try Etoa. Is that in the where is that from though? Is that stdio or is that cmath? stdlib. Okay, let's try that. Let's see if that works. Etoa means integer to a, I guess string, integer to string, whatever. Non-standard function. I don't give a shit. So we need to store it in a string buffer, and then the integer is the radix. This is complicated compared to what I wanted to show him. All right, we're doing printf. Fuck it.
Printf it is.
All right, so there's something called print formatted, which C does support, and I guess that is their int to string, to be honest. Without having to make, we could make the functions, but I didn't want to go that into it.
What about puts?
We did puts. That's the print.
Okay.
Puts only does raw strings, so that's our we've hit the limit right here. So there's a thing called printf. So the way printf works is first you give it the string, and the string can have a format to it. So you can put blah 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 here, but you can also do something called a percentage sign, or modification or format sign, and you can provide it a type or a literal type that it supports. So if you want to see all the literal types, they're all down here, and it tells you all the codes you can use. For an integer 64, it is an LLD, I think. LLD. So that stands for long, long decimal, or long, long int in this case. I don't know why they use D, but they do. And then what you do next is you put a comma. So depending on the number, this is called, oh, by the way, use printf, don't put print. And then, because we're using printf now. And depending on the number of format things, the number of commas you can put. And these comments are the format arguments, so what this thing is going to be. So in this case, that thing right here that we're going to be printing out is our loop time elapsed. So after the comma, you put loop time elapsed. Just like that. And it just wants the address to it, as you can tell by the format. So if you look at the format, it should tell you that those 3 dots are the address to whatever the thing is. So yeah. And then because we want to make it a new line every time like in puts, but you have to do it manually here, use /code n, and that basically says put a new line for the string. So now if you build that, take out your break. Okay, it doesn't like something. Does it want me to put data instead? Yes, it wants the data. It doesn't want the address. I keep getting it mixed up with something else called scanf. So put data to loop time elapsed. Take out your breakpoint, and then press local Windows debugger and let it rip. And you'll notice something. A spam of numbers. That's how many ticks per loop. And if you notice, it's pretty damn fast because each loop is around 25 microseconds on mine. I don't know about you guys. So it's gonna be time, loop time elapsed.
It's like 36-ish.
Yeah, it will jump around for sure. Mine's acting up because it's fucked around. I'm trying to reset mine. Oh, come on. Clean solution. Build solution. Run a clean fucking goddamn console. There it is.
Shut up. Jeez.
There we go. Yeah, it's around 25 to 30 something microseconds. Keep in mind, convert 32 microseconds in Google.
Is it /n or /n? Backslash.
Is it forward slash? That's a forward slash, and closing parentheses. I think it's forward slash. Let me see. I don't know what they're called. I use forward slash.
Back is like it's like
The one in the bottom corner is backslash, right? And the top corner is forward slash.
ah.
Okay, that's the way I memorized it. So.
You got it.
Oh fuck.
Oh, did you see that? It's crazy.
Okay. So you have an error. Missing parentheses. Did you close your format? No, you didn't. There you go. Run it. Well, take out the breakpoint first. Okay. So, uh-oh.
I broke it.
It's okay. Take it. Close. Stop it. Stop it. Take out the breakpoint. No. The breakpoint. The red thing.
Sorry, the red thing?
Yeah.
Which breakpoint?
The red dot.
Oh, sorry.
No problem. Now run that. See if it fucks.
It fucks.
Heap corruption. You didn't do an allocation. So close. Let's go look up. But why would he get an heap allocation? We didn't deallocate. It should have been okay with that, to be honest. I'm trying to figure out what's going on. This is a runtime error, so notice we don't have a compiler error. So this happened during runtime, which means now it's a little bit more harder to figure out what went wrong. But we still can. The burr. Let's see. Go up to the top where your allocate was. Yep, your allocate hasn't been updated. You're still using size of character times 13. Change that to size of hello world and add size of time date to a 2. So no. Delete delete all that except for the boolean and the plus sign. Because again, this memory block is holding all our data. So now you're gonna put size of hello world, that macro we made earlier, that determines the size of all our characters that we're allocating.
Yeah.
And then we're gonna be adding the size of time date. So, and that will be our full block of memory again. And that's times, or that's a plus, never mind, it's just my blurriness. Size of time date. Yeah. It's whatever you called it up there. So you have defined size of time date. That's what I'm seeing.
Yeah.
And remember, it's a macro, so replace all the code there with that. So just close that parentheses if it's not. Which I think that's what it's complaining about right now. And we should be good to go. So now if you try pressing play, we should have the memory to fuck with. Yay! Okay, but your loop is not looping, so
Yay.
Close it. We're getting there. Don't worry. Go down. Why is your loop not looping? Go down. Go to core engine loop. It's there. We never changed our exist. What's going on here? Put that brace right next to the if statement. No, the upper one. Yeah, close that gap. Put a tab just to keep it aligned.
Oh, like underneath it?
Yeah, there you go. But just make it aligned to the if. Aligned to the if. That's the scope. Yeah, that's the convention. So then press start again. Or breakpoint it. Cause I don't know what's going on. Is your exist? You might have to check your locals. We're gonna have to see if your exist is having its value changed. So just it's true 205. That means it never got assigned.
Wait, what did you say? It's true 205.
Yeah, because it's only supposed to show true. That means it has a higher value than 1. So that means
Where do you see? Oh. Here.
right there. You see, if you open it up, you can also see the value. If you open up that little star, that little triangle, there it says true 205.
It's not supposed to say true.
It's supposed to say true only, so that means we never assigned exist properly. So go up.
We is a nice way of saying I.
It's okay. Go down, down. It's in our main. It's the next one, somewhere other place that you have exist. So that's our call. We did exist equals memory block. So yeah, we have to do the exist equals the data of exist needs to be true though. We never did that. That's our problem.
So where would that go?
So that would go right after your message, your address assignment. So you did the address equals memory block. Now after that, we're gonna say data of exist is going to equal true. Just like that. So now if we run it,
Oh, I saw the breakpoint.
so yeah, just press continue. Now let's check your window. Zeros. It's okay.
Ow.
We're getting there.
Fuck.
Go. You're getting there.
I'm blaming the breakpoint. There is no breakpoint anymore. Alright.
Okay. No, it's not the break point. Calm down. No, just stop. Stop. Wait. Let's read the code because doing the same thing is not gonna help us. You don't put the comma after the LLD.
Okay.
Press start now, and that should remove the comma but not fix our number problem. Okay, so there's some math went wrong here. So press the stop or that. Okay, you are missing an operation. So you did the multiplication of times microsecond offset, but you never divided it by the frequency. So you have to paste this code. I'll just give it to you. So you have to put the time frequency there. No, can you do that? Yeah, you could do it on the same line, but I was keeping it separate.
Oh, alright, I'll just copy what you put.
You would have to put a parentheses if you're going to put on the same line, so it does the multiplication first before it fucks with the frequency. But oh no, you deleted your last thing though. There's three operations. There's time loop elapsed quad part minus time snapshot end minus initial, then multiply it by the microsecond offset, then you divide by the frequency, and that gives you your number.
I didn't delete another one.
Oh, okay.
I guess I just never had it.
No, don't highlight it. Don't highlight it. Press enter. Yeah, delete that. Press enter and then paste the thing I gave you, and you should be good. So the next one, you see I'm setting the time loop elapsed divided by the frequency. So now if you press play, you should get a number. I'm hoping.
That's not 0.
That's not 0. Okay, it's okay. We gotta. This is a good. Unless he's that fast, I don't think he's. No, there's no way in fuck. Well, press stop.
Dude,
Breakpoint. Breakpoint the if statement. We're gonna check our locals. Okay, press continue. Local Willis debugger. All right, let's look at the locals here. So let me open this up. Press F11.
Fuck. I broke it.
No, it's okay. I just want to keep track of this.
Okay. Continue.
Expand that a little bit because I need to be able to read the values it has, or else I can't see anything. Yeah, I know, you gotta get used to the UI. Okay, so then snapshot that. So we have a frequency, we have that. It's not that.
There's a snapshot for this bitch.
Type snapshot initial and end. We have to press F11 to get them. So press F11 once. Okay, so we got the first snapshot, it's 1,000. You're using the frequency function. you have to use the counter function. So there's two functions we're using. The frequency function, which we only use once, and that's to get the frequency of the ticks. And the next one we use is called query performance counter, which gives us the amount of ticks that have passed.
And that's for the last.
The last one and the first one. The first beginning part. So it's query performance counter.
And up here too?
Yes.
Instead of frequency?
We only use frequency before the loop. And now you can press stop, rebuild, and we can see if it gives you... You should be good now, so you could probably remove the breakpoint. So press continue. Yay!
Wow. I'm a big kid now.
So
There it is.
you have a time system now, something that can track your time of your program's loop count, which now means congratulations, you have a delta time.
Wow.
So
I don't know what I got, but I got it, boys.
you got the basis of the physics engine's core thing that it needs from timing in order to do all its physics calculations right. So now that we have that, it's in microseconds. It's not nice to read microseconds. So let's convert that to something like seconds.
Yes.
So I don't remember the math for this. What is a microsecond to a second? We need to do an offset calculation for this shit. We'll start by first. Let's get a decimal out here. We need to use the decimal system, so we're going to be using floating point numbers. Do you know what a floating point number is?
No.
So IEEE, their big tech group association kind of thing, they defined a format that's called the floating point number. You can find it in C reference. So basically, instead of putting integers in here, they do what's called a float format. And the float format basically tries to make an approximation of a decimal number. So now we can have the 0.00 something up to a certain accuracy. If you go to language, arithmetic types, and you go down to real floating types, there's 3 different versions. There's a 32-bit decimal, which is called float, a 64-bit called double, and an extended 64 called long double.
Yeah.
We'll use long double, and it has a range of 19 decimal places, I think. So
Goddamn.
accuracy to the fucking moon.
Yeah.
So we're gonna, to make a long double that's nice to write, we're gonna define a new data type macro. So we're gonna say float EP, which stands for float extended precision, and we're gonna say long double, which makes sense. I'm using double, to be honest. The reason they use double because it was double of float, but to me that's a dumb name because it doesn't last the test of time, because once we have 128, we're going to be calling them triples. That kind of starts feeling dumb. So yeah, now I'm going to be putting here in the address float EP. So we're going to be making an address for a float extended precision, and we're going to call this delta time. And the delta time is going to be in seconds. So I'm going to put a comment saying in seconds. And I'm calling it delta time because this is really what we're going to be using all the math for. All our math is going to be on this shit. So we need to give a memory block again our size of our EP, so we can have some memory that we can use on that address for our float. So we're going to say size of float EP and give it to, and that's going to be put here now. And now we have an address we can give it. So what we're going to do is, after the address for loop time elapsed, we're going to put the address for delta time. So we're going to say delta time, the address of delta time equals address of and float EP, because we're doing a conversion after this. And we're going to say the location of the offset is going to be loop time elapsed plus 1. You can see a recurring pattern here. It's just 1 plus every time. And we're going to be setting the initial value of delta time. So data delta time times value will be set to 0.0. I think it's yeah, you can leave it at 0.0 because the default floating point literal is double, not floats. So we have to put an F. So you put 0.0 though, that'll initialize it. And the next thing we have to do is now set. So that just takes care of this, because we're gonna be doing a printf here in a moment. So we're gonna say data, and we're gonna calculate the delta time now from our loop time elapsed. So we're gonna say delta time equals. So now we have to figure out the conversion from a microsecond to a second. So let's find that out. How do we? I think it's e to the 7. Oh, e to the 6. Close. Is there a math to it that I can copy? So we just multiply it by the amount. So it's going to be, is that 10, is that 6 zeros, Hazar?
Yes.
So we have to divide it by 6 zeros.
5 zeros, 5 zeros.
Oh.
Because one of them is the 1.
Okay, so we're going to divide it by 1 and 5 zeros.
Mm-hmm.
So, yeah, so now we're going to say define time, loop time, 2 seconds. And that's going to be 1 and 5 zeros. Okay? So now we're going to say the data of loop time elapsed divided by our loop time in seconds.
You have 6 zeros.
I do? Yeah, I do. You're right. And I also spelled this wrong. All right. It's going to be divided by the loop time in seconds. But to make sure there's no... Remember, this is dividing an int. So if we did this, if you didn't know, when you divide 2 ints together, you lose the decimal. That's the whole point, was we're trying to preserve the decimal by using a double. Extended double. So what you need to do is you need to convert these things before you do the division to double. So that means you have to do a casting operation. So the way you do a casting operation is you put parentheses before both of them, like this, and you're going to convert them to a float EP on each of them, because that's that will turn them into floating point numbers, which we can then divide and retain our information on the decimal accuracy. So now that should take care of our calculation for delta time to seconds. And what we're going to do is we're going to print that. So now we're going to give it a nice print statement. Let's give it something that's not shitty. So we're going to say it's going to be seconds time, loop time. We're going to put parentheses seconds, and then we're going to put a colon space, and we're going to put whatever the floating point EP is. So I need to find the format for printf long double. So printf long double is long float. Maybe I gotta find this shit. Long float. I'm looking around for it right now. Double or float in decimal. Just put long double. We'll try that first. So long float. And then we're going to put data to delta time instead of data to loop time event. Like that. And that should give us a really nice thing to read. And yeah, we're going to try that. So when you guys are ready, let me know. And this will be the last thing we do today because I didn't realize how much stuff I put for session 4, to be honest. So I'll start mine up. Let's see if it even works.
Damn it.
Nice. You got an error? I'll help you right now.
I got an error, yeah.
Let's start with you, Hazar. Oh, wait, you're good?
I mean, it did say succeeded, but I did get a warning. Is
Oh,
that okay?
press play. See if we get something going. Where's your... Nice.
Oh.
Let's look at Nyx. How's Nyx doing?
Nick needs to define delta time still.
No, you don't. You only defined one thing. Delta time was supposed to be a declaration, not a definition of a macro.
Okay, there was supposed to be. Did we make another macro?
Yes, we did. We did make another macro. Let me go look for it.
Was it the float EP?
We did make a float EP macro. I don't know if you
that's
made
the one
that
I
yet.
missed. No, I missed that when you were writing it.
No problem. If you're macroing data types, make sure to put them outside of main. There's a reason why. It's because when you do data type definitions, they shouldn't be inside of a function. That's why it's just a conventional thing. You could, but don't do it. Put them where we put the data definitions, like right there. Yeah, exactly. And then you're gonna put long double. Almost at the end of the stretch here. Okay, so did you define delta time? We need to define delta time as an address to a long double. So we need to go all the way up to where we define. Oh, there is a delta time there. Scroll up a bit. But we didn't put you put address float EP delta time, but you didn't put a semicolon after the delta time.
Alright.
How was he able to run it? It's weird.
It might have just done the last good build. Sometimes Windows will do that. In order to avoid that, press Control-Shift-B or press the build option instead of the local Windows debugger because it won't run. It'll just build for you. So we got 4 errors. So go to output. And it's saying that your syntax is wrong for your 184. So here, you forgot a closing parentheses, I think, on your address float. Yes. You see how there's a yellow to yellow? That makes no sense because you had a pink at the start or a red there. So you're missing a closing. Not there. Look at your other patterns. Look at your other patterns. You've done the 3 times. There you go. Now you found... I'm just saying, like, if you can't remember, just look at the last thing you did. That's the way I remember stuff all the time, dude. I just look at the last thing I did half the time. It's one of the programming skills you build is like, present me can't remember shit and has dementia. Let's look at what old me did.
There you go.
So let's try building that. It still gives an error? I didn't notice. Okay, let's look at output 213.
Well, I'm over that line. Though.
Yes, exactly.
It wasn't
Step by step. Take every single error that you beat is like a water bottle flip. You take those.
Alright.
Trust me, like when I have had a program that didn't compile for an entire day. You take those. Loop time seconds. LLF. Try LF instead. Because I think that's the problem. I think LF means it means long double apparently, or long flow too. Output. I think it can handle extended doubles with the thing, but we're calculating it that way anyway. I don't care. 134. What did he do? No semicolon. And that parentheses there is useless. No, it's not. You didn't put a data. Notice that you were trying to do a data, I think, and you lost it. So it's supposed to happen after the float cast. So you do it after the float cast. You put a data and an open parentheses because you already had the closing. Perfect. Build that. Let's see if that works.
Stop.
One more to go. 234. No object file. Conversion from double to int64. You assigned it to loop time advanced. We want to assign it to delta time. So if you see you have data loop time advanced equals this division, we want it to be equal to delta time. So look at your first statement of the expression, your first term of the equality expression of statement. That needs to be a delta time. The very
first.
Yeah, because that's where we're basically storing the decimal in.
Yeah.
Okay, here we go. That should be it. We should be good now.
Hey.
We're getting 1 though.
Yeah.
We messed up the math somewhere.
I didn't put float EP in any of those.
That probably fucked you up too. Let's go. So let's see what's wrong here, because that division's correct, right? No, it's not. Look, what you're dividing the same thing.
Yeah.
That's our getting ones.
So you need to convert the. You're not using data there. You need to use your. Did you ever make the macro for the time to seconds? The microseconds to seconds.
Yeah, it's time. Offset.
Yes, perfect. Now let's try building that.
Still.
Perfect. Oh, okay, he's got it. Look how many. That's how accurate your engine is right now.
Wow.
That's how fast it's doing each loop.
Crazy.
Perfect. Okay, so that's awesome. So let's get Hazar, and I can explain what the next session is going to be. It's because we don't have time tonight.
I got 3 more decimal points.
Wait, is that correct?
Wait, what?
Wait. Oh, it can do long double. That's why you're getting the extra decimals. Hey, Nick, change your thing. I'm gonna change mine right now. Put LLD. You can do it. That's why he has the extra. LLF. That's why he has the extra numbers. Wait, what the fuck? Hazar? How are you getting extra numbers?
I don't have LLF.
You said
how-
LLF.
How are you getting those extra numbers?
I thought it was.
Hazar's cheating.
It was that fast.
No way. No, you're
Look.
getting extra numbers. Where the fuck?
Well, look.
LLD. That's the wrong thing.
Where? Over
You put
here?
you put a 64-bit integer, but it's still shitting out something okay. It's supposed to be LF on your printf. Oh wait, you're printing out both? Ah, I'm having that Dima moment right now. You're printing out both numbers. You're printing out the ticks and you're printing out the delta time. That's what we're seeing.
What should I delete one of them?
Just comment out the first one because you might want to put statistics on it later. So just run that, and now we'll see exactly the same thing that we're seeing on our side. Oh, never mind. Keep it LF.
Oh, brr!
What happened? No, don't have a new line. Why is it not printing out a new line? You do have a new line though, right?
No, I don't. The new line was on this one, not this one.
But it shows it right there.
Oh, that's A.
What does the A mean?
I don't know. I thought I saw it on yours.
Oh no, we don't have an A. We have an LN.
LF and then Sasha N, right?
Yes. Exactly.
Alright. And yeah, that was the reason.
Okay, so now everyone's on the same page. So now the annoying thing is, and this is what we're going to fix next session because we're out of time. We went way over. But I hope this was cool at least. We're going to be...
I'm a programmer.
We're going to be making next a clear console buffer. And I'm going to be doing that step by step with you in the MSDN next session on Friday. Not today.
Okay.
Also, Hazar, on Saturday we're doing physics homework.
Alright.
Because otherwise, that's the only time I have, to be honest. Sunday I have to reserve for every exam. Every week almost, I'm going to have a math exam. So Saturday's my day for physics.
Alright.
But yeah. What we're going to be doing next, ignore the session numbers in the TBF thing. Right here, there's an outline of everything, but these numbers are no longer relevant. That's a fucking high speed though. That's really fast. We're gonna be putting more information, but first we need to put a clear console buffer. So that's what's gonna be next. Is we're gonna be there's this. We did the put a comment markers. We need to set up a clear console routine. And then after we do the clear console routine, we'll do basic input polling. And if you want to see what the clear console routine is going to do, because I did this a while back, it looks like this GIF. So we're going to be making one of these suckers. This is how nice our timing system is going to look with all our little pretty prints. So yeah, that's this has extra stuff because I didn't use high precision, and this was TBF v1. But you see how it's all on the same lines. It doesn't keep scrolling down. Clear buffer is going to do that for us. So, and we'll be using frames per second to help this flicker not happen that you're seeing in my GIF. But yeah, that's what you can look forward to. And after that, there's only one. Let's see. How long until I throw you into the ocean? Just so you can keep in mind. Clear console. Then we make the input polling so that we can press like Q to quit. Then we're going to stop development to do procedural programming. I'm going to introduce stack memory management, type def and aliasing, elums, functions, while loop, and the do while loop, and which are basically we already have but nicer and cleaner to write. Destruct, which is basically a data structure, compound data structure, object structure, or it can be a bit field too. And after that, the header file and the smart memory. So there's a lot to still do. So there's a lot of time for you to still get used to C before I finally make you do stuff yourself. Alright, well, that's it for this session. Congrats, you did a lot. You did a core loop. And you have a basic timing system with a proper delta time.
It's pretty awesome.
Yeah.
You're fucking awesome.
If you use Unreal Engine, if you start messing with Unreal Engine, Nick, you'll see delta time. Trust me, we use it all the time.
All the time.
I mean, it makes sense that you would use it.
What?
It makes sense that you would use it.
Sorry, it was not you I was talking to. It was my dad. That's okay. They were telling me something.
How dare they?
Yeah.
Go learn them some manners, dog.
So
No, I was saying that it makes sense that you would use.
Yeah, we all the time, because if not, then like if you have like 120 FPS, your physics would be twice as fast with everything it does. So yeah, everything's extremely relevant to game development if you were interested in that right now. Obviously.
What's FPS for Dark Souls?
30 and 60 with a mod. If you're talking about Dark Souls 1. If you're talking about Dark Souls 2, they finally fixed their engine. It's not locked 30 FPS. In fact, that actually shows you one of the issues when people lock their frame rate to FPS, because if you run it at 60, all fall speeds are locked to FPS. So everyone falls faster in Dark Souls 1 when you run it at 60, which actually makes the game harder. Or I think that was Kingdom Hearts. Sorry, that's Kingdom Hearts. Kingdom Hearts has this fall speed locked to frame rate. a lot of old games used to do than a lot of console games did, because here's the thing, like, why would they calculate a delta time if they knew the frame rate was going to be permanent for the console? So it's more, instead of wasting math, it's any processing resource on doing delta math, they just do it by frames, because it's just way more cheaper on processing to do that kind of math that way. But what happens is on PC, you're not always guaranteed to run at that frame rate. People like their 144 to 248 hertz monitors and different resolutions, and sometimes they don't lock their frame rate. They like to use VSync and variable frame rates and all that stuff, so you can't get away with that anymore. Plus now even like the PS4, I'm pretty sure lets you switch between 60 to 30 on some games by sacrificing graphics, so they're becoming slowly like PC.
Yeah, I don't know.
But yeah, that's just a summary of how that's important. But yeah, that's everything. I'll shut down the stream now.